Hello, everyone. Now we're going to go over some things of hints on the project, some things that might help you out throughout the project. First things first, let's go over some of the things that you should already have seen. You must, in order to watch this video, you must understand the one-shot instruction, which you already have a video. You must understand the time on delay instruction. You must understand the set and reset instruction. And time on delay is the same thing, and making edits online. You definitely must see this one, so you don't take that long making this project. All right. So let's go over some of the specifications. Before that, we can even cover some of the details. So we have a tank with a high level switch, and a low level switch. When the low level switch is made, means this float is floating and it's aligned with the switch itself. Right now, it's looking downwards, right? So it's throwing a zero. I made it normally open. So if it's looking downwards like this, it's not floating in water or on the solution. It's a zero. It means empty. If it starts floating and it's aligned with the switch itself, then you have low level water. Same thing for the high level switch. If it's not floating, it's looking downwards, you have a zero. Once the water reaches a certain level, this little float starts floating, you're going to get a 1 because the switch is going to be aligned and the tank is full. All right. You're also going to have a mixer, a motor for a mixer. It's going to turn on the mixer to clean the walls of the tank. 2 pumps, one with a cleaning solution, one with the water, and a drain valve which drains the entire tank. All right. Let's go over some of the specifications now. So the water pump will be wired and programmed to output Y4. The clean solution pump will be wired and programmed to output Y5. The motor for the mixer is going to be wired and programmed to Y6. The drain valve opens when output Y7 turns on, so it needs to be programmed and wired to Y7. The high level switch is normally open. All right. And it's connected to X10. All right. So when X10 is 0, the level has not been reached. When X10 is 1, the high level switch is reached, meaning the tank is full. So going back to our little drawing here, same thing I explained just a few seconds ago. When the high level is reached, the float, it's going to be floating with the water. It's going to be aligned with the switch. Instead of looking downwards like it is right now, it's going to be aligned with the switch. It's going to throw a 1, meaning the tank is full. Okay. So going back to this, then you have a low level switch, normally open, connected to X9. I'm sorry. Meaning if low level switch is 0, meaning X9 equals 0, the low level has not been reached. The tank is empty, fully empty. Going back to our drawing. So this little switch is looking downwards, it's thrown a 0, meaning the tank is empty. There's nothing in there. Once the water starts rising, the float starts floating with the water, and it's going to be aligned with the switch. It's going to throw a 1, meaning the tank has a low level water or a solution. It could be either one. Okay. Going back to our specifications. We were at the low level switch. When the low level switch equals 1, the low level is reached. There is some level of liquid, approximately 5% or more of the tank, right? So if it's 0, the tank is empty. If it's 1, you must have something in there. It's going to be 5% or more in our case. The system is started with a normally open momentary start push button connected to X0. The system is stopped with a normally closed momentary stop push button connected to X1. The system can only be started when the tank is empty. If not, it's going to remain at step 0, and we're going to discuss that pretty soon. Before the system is started, the output Y0 it's going to be a green light is on. When the system is started, output Y1 before the system. This is before the system is started. Y0 will be on, meaning the green light. Once the system is started, the output Y1 turns on, a red light is on, meaning we're undergoing cleaning. All right. Every step of the process will be moved into a memory location V1 address. All right. So we're going to use that V1 to see the steps that the system is going through. Before the system is started, the system will remain in step 7. You can program this step at the end as it is the last step in the sequence. So I'm already telling you, program it at the end since it is the last step of the sequence. Once the system is started, it will move to step 0. Note that step 0, I'm just telling you right now, step 0 is not an actual step, it's just a verification. That's why I call it step 0. It will verify that the tank is empty. Low level switch equals 0. If the low level switch is 1, the drain valve, first of all, you have to understand what's the low level switch equals 1 means. So if you go back here in the low level switch, so when the low level switch is 1, low level switch is reached. There's some level of liquid in the tank, right? So since there's some level of liquid in the tank, the drain valve opens until low level switch reaches 0. Else, we will move to step 1. So the system would say, "Hey, I'm empty already, so I'm moving to step 1." I can add it here until the low level equals 0. Use the normally closed contact to evaluate this. All right. Actually, I'm not even going to code it. You can use whatever you want. All right. The drain valve opens until the LL0 is there. So don't use it. Actually, you should use a normally open contact for evaluating that it's there. You open the drain valve. Once this turns off, which means you have reached a low level switch of no level in the tank, then your drain valve closes. And I can show you that. All right. Once, and I can put it right here. It's going to be very repetitive. I mean, copying the instructions. Once the low level switch actually we can put low level switch and high level switch, meaning this is just a verification, are made, actually R0 or are not made. What does that mean? Well, low level switch equals 0 and high level switch equals 0 at the same time. The system will move to step 1. During step 1, the tank is filled with the cleaning solution. So that means if you go to the drawing, just imagine. I start pumping. I'm in step 1. I'll start pumping cleaning solution. The tank starts filling, and you want to stop filling when? Just use common sense for this, right? So once your high level switch is made, I want to stop my cleaning solution pump to turning. I want to stop it from pumping, right? So you want to turn it off. So filling with the cleaning solution until the high level switch is reached. Once the high level switch is and the low level switch are made, the system will move automatically to step 2. During step 2, the mixer starts for 5 seconds on, 5 seconds off for 60 seconds. We're going to call this timer, which is going to be a 60-second timer, a cleaning timer. Then use an equality to state when to turn on the mixer. Once the cleaning timer is done, the system will move to step 3. During step 3, the drain valve opens until the low level switch is made. Okay? It's not made. Okay? Once the low level switch equals 0 and the high level switch, look, this is different, right? So this is opening the valve. This is the condition to open the valve. Says the drain valve opens until the low level switch is not made. And I'm going to show you this on the program. Okay. Which step is this? Step 3. So I'm in step 3. Right? And move 3 to the step V1, to location V1. So, and this is the pointer right here. When V1 equals 3, all right, and you could program this just like that. V1 equals to 3, all right? And my low level switch is 1. I'm going to execute step 3. And what is step 3? If I go down further, step 3, drain valves. So the drain valve is open in step 0, step 3, and step 6. So look at this. Look what it says here and compare it with the specifications. In fact, I'm going to copy the whole thing. Step 4. So in order to see these comments like this, like I put, you can click on it on the rung that you want to put the comment. And then you're going to insert, actually not insert, comment editor. I want to add it right here. I said okay. During step 3, so basically this opens the drain valve, right? During step 3, the drain valve opens until the low level switch is not made. Low level switch equals 0. So this opens the drain valve. So while this is 1, it's going to open, all right? Once this becomes 0, during step 3, it's going to put a 0 to the drain valve, shutting off the drain valve, which says until the low level switch is not made equals 0, right? So how can I evaluate that? Normally open, while it's 1, it's going to open the drain valve. When it goes back to 0, then I stop draining, right? Then it says once the low level switch equals 0 and the high level switch equals 0, the system can move to step 4. Then this part of the sentence is not here. It's going to be right here. So once the high level switch and the low level switch are not made during step 3, I'm going to use this one shot that goes from off to on. When this whole rung, everything in here becomes from true, at that instant it goes from false to true, meaning from off to on, I'm going to move a 4 into B1, which right now you have a 1, but initially you had a 3. And this is during step 3 only, right? You want to make sure this is on each and every step. What step were you in and what step you're going to move to. So you're going to add this little instruction right here. So when you move a 4, so if I take this off and I move a 4, this is going to be always true. If you watched the previous video, you know that this only turns on for one scan time. It's going to turn on for one scan time. That means on milliseconds. We already discussed this part, right? So it's going to turn on for, it's going to pulse, I'm going to throw a little pulse for a millisecond range where it's going to put a 4 into B1. If it wasn't for this, you're going to have a 4 there permanently. And then when you go to the next step, it's going to say, no, this is going to happen. Then when this switch and this switch is made, and this, and I'm taking this off too, I'm going to move a 5. But you already have a 4 over there. So is it 4 or is it 5? This is why you need to add this little instruction here. You need to add this. It will not work if you don't add this instruction here. Another thing you can do is also, instead of this, you can put one-shot contacts on here. I do not recommend that right now. Not for, because if the level starts bouncing around on the tank, then it might cause some issues. I would use this. So when this whole rung becomes from false to true, so obviously your high level is going to go first, right? Then you keep draining, you keep draining, you keep draining. Then you reach a very low level. Then this one's going to go false, right? It's not, and then it's false. Since it's normally closed, it becomes true, right? So you say during step 3, now I know that my tank is drained. So it goes from false to true, throws a little pulse, it moves the 4 into B1. Now, it's not constantly true. It's not moving the 4s to all the every scan time there. It just moves it for one scan time, moves a 4 to B1. So now you got a 4 here. Now when this happens, this becomes full. All right. Now I'm no longer moving a 4. I already have a 4 in there. So now it's gonna go do the same thing. It's gonna move a 5 for one scan time. And since this instruction, once you move it, it's there permanently until you move something else to it. So it moves a 5 to B1. You can experiment with this on your own as well. You can try it on your own. And there's a video on it as well. All right. So you want to put this instruction before it. Okay. During step 4, the water pump starts filling the tank until the high level switch is made. Once the high level switch equals 1 and the low level switch equals 1, meaning the tank is full, the system will move to step 5. So let's go into our program. So you were in step 4, right? So in step 4, it tells you, during step 4, the water pump starts filling the tank until the high level switch is made. So I start filling the tank. Once my high level switch is made, I no longer want to fill the tank, right? So when it's not made, when it's made, I want it to turn off, right? So high level switch becomes 1, and this saying, hey, no, you're already full, so I'm going to cut power to it, right? Meaning there's high level switch. The high level switch has been made. I'm evaluating here that when my high level switch is made, I don't want the step 4 to keep filling up my tank. All right. During step 5, the mixer starts for 30 seconds on. All right. And we're going to call that the rinsing timer. Once the rinsing timer is done, the system will move to step 5. So when I'm in step 4, and I already know that I am completely full, meaning my low level switch and my high level switch is true, I'm going to move a 5 to B1. And then during step 5, I start the 30 seconds timer, right? So I'm in step 5, 30-second timer. All right. Timer timing. It starts mixing my tank for 30 seconds. Look what it says here now. Once the reheating timer is done, the system will move to step 6. Once my reheating timer is done, and I'm in step 5, put always this instruction right in front of my move, I'm going to move to step 6. Now I'm going to be in step 6. And what does step 6 says? During step 6, the drain valve opens until low level switch is not made. So, step 6, low level switch. I'm going to start, draining the valve, opening the drain valve, draining the tank. All right, draining the tank, draining the tank, draining the tank. Now, once my low level switch is no longer made, I don't no longer going to have a 1 here, right? I'm no longer going to have a 1 here. Let's put this one in perspective just so you see it. Mm-hmm. Mm-hmm. So, once your drain timer and once your mixing or your rinsing timer is done, in step 5 you move to step 6. In step 6, it says you're gonna open the drain valve. There's a drain valve in step 6, and I'm gonna show that to you pretty soon. You're gonna open the drain valve in step 6. This is basically a permissive for the drain valve. I call it step 6. All right, and so you're gonna in step 6, you're gonna open the drain valve. So you have your water level is full. So basically, if my water level is full, let's use this marker right here. You have water level here. And you start draining water. Start draining water. Your valve has a 1 there. So you're telling it drain until low level switch equals 0, right? So if low level switch equals 1, it means there's water in there, right? There's 1. Let me put it right here. And then I put, if I'm equal to V1 equals step 6, drain valve, right? Drain. So if I put 1 here, I'm going to pass flow to the drain instruction, right? So I'm draining. I'm in step 6, the low level switch. Obviously, it's going to be made because I have water in the tank, right? So once the tank goes empty, let's say initially it's going to go around here, and you're already empty, your level switch, right, it's going to turn on, it's going to turn to 0, right? So if I have a 0 here, this is no longer true, right? This instruction is no longer true, even though I'm in step 6. So I'm going to stop draining. So my drain valve is going to turn into a 0. All right? My drain valve is going to turn to a 0. Okay? Then it says, once the low level switch is not made during step 6, the system will move back to step 0. I added the high level switch as well. I'm adding it every time I move through steps because it's easier to simulate and it's a verification. Hey, if I'm going to say the tank is empty, both switches should be off. So, meaning, in this case, I am draining because my switch is on. Until my switch is off, I'm not going to stop draining. And this is what it says there. So look, until my switch is off, I'm going to keep draining. If my switch is on, I continue draining because there's water in the tank. Now, to move to step 7, I'm saying, well, am I empty on the low level side? All right. It will not make sense if I say, hey, I'm empty here and I'm not empty on the high level switch. So in order to be empty, unless water floats on the tank, I should be off here and off here on both of them. Meaning, what does off mean? Means I'm off. The float switch is no longer floating in water. And I doubt it floats on air. So I have a 0 there, a 0 here. While in step 6, I'm always going to add this little one shot that's saying, hey, when this is true, from off to on, I'm going to move during one scan time. I'm going to pulse a 7 to V1. Just put it there, bam. That's it. I'm no longer going to execute this instruction anymore, unless I go back through the cycles, end up in step 6 again, and this becomes false, and then it becomes true again. All right. I also added, so the specifications, if I go back to my specifications, during step 7, the permissive to start is during step 7, the permissive to start is reset back to 0, meaning your Y0 is green light and turn on, and waits for the operator to initiate the next cleaning sequence. Basically, it's saying, hey, I'm idle. You guys initiate an additional cleaning sequence. So, let's say I stop the system in the middle of a run. All right. If I stop the system, your permissive is not going to be true. It's going to move a 7 to V1. All right. And in V1, in step 7, once I start it again, it's going to go back to step 0. I'm sorry. Once in step 7, it's going to reset my conditions. If I'm not mistaken, that should be true. Yeah, if I'm in step 7 and I'm permissive, I'm going to reset my C0, my permissive, meaning I'm going to shut off and be ready for my next cleaning sequence. But I'm still in step 7. Okay? Let me verify something. So you notice I reset. Now my permissive is reset. I'm in step 7. Okay? So let's say my low level switch, which is X9, is made. What does that mean? That means this is normally open, there is some water in the tank. And I start the system, right? The X1 is my normally closed stop. So if I start it, non-permissive again, took me back to step 0. Okay? Now it's trying to drain. I can add it right here if you want. So you can add it. So you can go to documentation editor. Was it C100? Drain. This is basically your drain before starting. All right. So I'm in step 0, right? So I'm draining. If you go down here where I put all my actual outputs, drain valve. Drain before starting, step 0. Notice that I put my outputs at the end of my program, all the actual outputs, all my Y's. And then use the C's for each step to turn on the output. So step 3 is going to turn on the drain valve. Step 6 also turns on the drain valve. Cleaning solution is only turned on, the clean solution pump is only turned on during step 1. Mixer motor is only turned on during step 2 and step 5. Water pump on, it's only turned on in step 4. Then green light, that one I will let that one to you guys. You guys can figure that one out. All right, so it says here low level switch, I'm draining my tank. So once my low level switch is no longer made, meaning the tank is empty, I have drained my tank, what's going to happen? So step 100 ends up being nothing, and I move to step 1. Now I'm in step 1. Okay. That is step 0. Kind of move a little bit fast. There you go. So this is step 1. So I move to step 1, and I move when my tank is fully empty, meaning low level switch is not on, high level switch not on. I went step 0, and I am permissive, meaning I started the system. So in step 1, I'm going to fill my tank until high level switch is made. So in order to carry out a good simulation, if I'm filling my tank, all right, with cleaning solution, and if you look here, step 1, cleaning solution, go down to the bottom, you're going to see the actual output that's being turned on. Just like our permissives to start, in this case, it's just a step. Use the same concept, right? C1, C101, step 1, I'm cleaning solution pump. That's the actual output turning on the pump. All right, so it turns on, and if you imagine your tank being filled, you first start by your low level switch is going to be made, right? Your low level switch is going to be made, and if I move this a little bit down to the bottom, your low level switch is going to be made, keeps filling up, keeps filling up, keeps filling up. Then your high level switch is going to be made, and look what's going to happen to here. Your high level switch is going to be made. Bam! You move a 2 to B1. Now you're in step 2. Timer started. Notice that I put 10 seconds here. There's going to be 60 seconds. This is your clean timer. You're going to use inequalities here to turn on your motor doing step 102, or actually step 2. Once you're done, it's going to move to step 3, which you already did it. Now you're in step 3. meaning you're going to drain the tank. It says it right here. Once the low level switch equals 0 and high level switch is 0, the system will move to step 4. So your step 3, V1 equals step 3, you're going to move a 4 from the source to the destination every time this run becomes true. And it's going to be true for a pulsating of milliseconds. Like really quick, it's going to be true and then come back to false. I'll go here. So first, if you're draining your tank, obviously your high level switch is going to come first. It's going to go off. You see, I turned off my high level switch because it's normally open. Notice my stop button, which is normally closed, still on. This one's normally open. Then my low level switch is going to be off. Bam, it's going to move to step 4. Now you're in step 4. When you're in step 4, what are you going to do? So this is right here. During step 4, the water pump starts filling the tank until high level switch is made. So high level switch is not made, right? So if you go back to your simulation, it's only logical that who's going to be made first, then your high level switch. Well, your low level switch, then you're going to have your low level switch is made. You're going to imagine yourself filling up the tank, right? Your low level switch is going to be made. Then your high level switch is going to be made. Look what's going to happen. Just so you see it. You're going to be made at step 5. And you're going to turn off step 4. Let's turn on here. Watch this one and this one and this one. High level switch, which is going to turn on right here. I turn it on, meaning it's full. It's full. So I'm filling up my tank with water to rinse it, right? So, bam, move to step 5. Now I'm starting my rinsing timer. My rinsing timer is going to turn on the mixer motor. Doing step 5, doing timer timing, step 5. If I go real quick, step 5, mixer motor turns on. All right. So once my timer is done, so doing timer timing, I'm going to mix. When I'm done, I'm going to move to step 6. Move to step 6. Now what am I going to do? I'm going to drain again. We go 106. Step 106 on the output side. 105. Drain valve, step 6. Bam, you're draining. So you're going to drain until your tank is empty. So if your tank is empty, first your high level switch is going to go off. So it's going to turn off. Then your low level switch is going to go off. So you move to step 7. So what I did is I put all these permissives in every step and then put my actual outputs on at the end of the program and just order the steps that turn on the output. This way I don't repeat this output 3 times on every run that I have step 100, 103, 106, which the output coils cannot be repeated. Notice that I did repeat the reset coil. That one you can. In this case, I repeated it and I added this one shot. So every time this happens, I am resetting back to 0. So if you notice that your program gets stuck, this due to like it gets like hard coded, like it doesn't want to move or something, because it might be that it wants to go to 2 different steps at the same time or 2 different stages at the same time. You probably want to use this wrong. Want to use this instruction. So right now, this is what I did. on every output. I OR them together on every step, even for the lights. And even on one of the lights, I use an inequality, right? I'll leave that one to you. When I start, I think that's basically it. I hope this helps you doing your program. If you have any questions, feel free. Try to figure it out as much as you can on your own. Thank you. Have a good day.